Hello everyone. In this video, let us see principle of reversibility and lateral shift. In the adjacent figure, ABCD is a rectangular glass slab. A ray of light is incident along KL on the face AB of the slab at angle of incidence I1 with the normal. It is refracted along LM at angle of refraction R1 with the normal. The refracted ray LM falls on the face CD at angle of incidence I2 with the normal and emerges out along MN at angle of emergence R2. So the light ray, in going from rarer medium to denser medium, the ray bend towards the normal, and in going from denser medium to rarer medium, the ray bends away from the normal. Okay, so let's apply Snell's law. Applying Snell's law at L. At L. Here refractive index of air is mu A and refractive index of glass is mu G. Again here it is mu A for air. Okay, so then we have formula as mu A into sine I1 is equals to mu G into sine R1. So we can write this as sine I1 by sine R1 is equals to mu G upon mu A. So this mu G upon mu A can be written as mu subscript G superscript A. Let me represent this as expression 1. Again let us apply Snell's law at M. Applying Snell's law at M. So we can write this as mu G into sine I2 is equals to mu A into sine R2. So this can be written as sine I2 upon sine R2 is equals to mu A upon mu G. This can be written as mu subscript A superscript G. Let me represent this as expression 2. Now, according to principle of reversibility of light, when final path of ray of light after any number of reflections and refractions is reversed, the ray retraces its entire path. So this is called principle of reversibility. Now in this ray diagram, imagine a plane mirror P held normal to MN, right? So that on reflection from mirror, path MN is reversed. The ray would retrace its entire path. So here the path is retraced from N to M, then M to L, from L to K by placing a mirror at 90 degrees. Okay, let's apply Snell's law at M. Snell's law at M. So if we apply Snell's law at M, then we can write it as mu A sine R2 is equals to mu G sine I2. So we can write this as sine R2 by sine R2 upon sine I2 is equals to mu G upon mu A. So this can be written as mu subscript G superscript A. Let me represent this as expression 3, right? Now let us multiply expression 2 and expression 3. Multiply expression 2 and expression 3. We get sine I2 upon sine R2 into sine R2 upon sine I2 is equals to mu subscript A superscript G into mu subscript G superscript A. So from this we can write is equals to 1 because sin I2, sin I2, sin R2, sin R2 get cancelled. Therefore, we can conclude it as therefore mu G A subscript G superscript A refractive index of glass with respect to air is equals to 1 upon refractive index of air with respect to glass. Okay, if we observe the ray diagram, then the emergent ray Mn is parallel to the incident ray KL. We observe that incident ray KL is displaced laterally on suffering 2 refractions through a glass slab, and this distance Mn prime, this distance can be called as lateral shift. So what is lateral shift? It is the perpendicular distance between the incident ray KL and the emergent ray Mn. So let us find out an expression for this lateral shift, that is the perpendicular distance between incident ray and emergent ray. So for this we need to consider 2 right angle triangles. Okay, so in this figure let us see 2 right angle triangles. First right angle triangle is LMN prime, which is making an angle here delta. Second right angle triangle is L prime and M. Okay, so this is a perpendicular. Here the angle enclosed is 90 degrees, and this is delta, which is equal to angle of incidence I1 minus R1. So if you want this delta, then we can write this as angle I1 minus R1. Delta is equals to I1 minus R1. Okay, so let us consider one right angle triangle, that is LMN prime, and second right angle triangle as L prime and M. Okay, let us find out sine and cos of these 2 right angle triangles. Sine for LMN prime and cos for L prime and M. By taking angles as delta for right angle triangle LMN prime and R1 for L prime and M. Okay, so when we consider right angle triangles, right? Let a triangle LMN prime is a right angle triangle. So from this right angle triangle, we can write sine delta is equals to mn prime upon LM. Here m n dash is what? D. This is the perpendicular distance D, right? So I can take m n prime is equals to sine delta into LM. Okay, now let us consider triangle L prime M. So from this I can write cos R1 is equals to L prime upon LM. So L prime is adjacent side, LM is what? Hypotenuse. Okay, so then we can write it as, okay, so LL prime is what? Thickness of the glass slab. So I can write this as LL prime is equals to T. So this is thickness of glass slab. Thickness of glass slab. So I can write this as, okay, LM is equals to LL dash is what? T by cos R1, right? So in the above expression here, LM we can substitute LM value where we have LM, right, in the given expression. So then I can write this as M n prime is what? Lateral shift, that is D. So D is equals to sine delta, LM is what? Into T upon cos R1, right? So here we know delta, that is nothing but I1 minus R1. So this is equals to T into sine of I1 minus R1 upon cos R1. This is what? Lateral shift D. Lateral shift, that is D. Here T is called thickness of the glass slab. Sine and cos are trigonometric functions. I1 is angle of incidence. R1 is angle of refraction. So we got expression for lateral shift, that is D is equals to T into sine of I1 minus R1 upon cos R1. Let us see the factors which affect lateral shift. Factors which affect lateral shift. Lateral shift. Okay, in that factors, first one is here lateral shift is directly proportional to thickness of glass slab. Lateral shift is represented here with D. It is directly proportional to T. Here T is called as here thickness of glass slab. Okay, so greater the thickness of glass slab, greater the lateral shift. Second factor we can consider as lateral shift is directly proportional to angle of incidence. Here angle of incidence is I1. So greater the angle of incidence, greater is the lateral shift. Third factor is lateral shift is directly proportional to refractive index of glass slab. So here, greater the refractive index of glass slab, greater is the lateral shift. And fourth factor on which lateral shift depends is lateral shift is inversely proportional to wavelength of incident light. So wavelength of incident light. So it is what? Inversely proportional. So we can represent inversely proportional as 1 upon lambda. 1 upon lambda. Okay, so inversely proportional, greater the wavelength, lesser the lateral shift. Okay, hope you have understood the expression for principle of reversibility and lateral shift and the factors which affect lateral shift. Thank you.